Okay, in this video I'm going to show you how to deal with regular square pyramids, and we're going to stick with square bases. We wouldn't have to, but we are going to stick with square bases. So I've got a little bit of terminology up here just to sort of familiarize ourselves with what we have. So we have the base edges, which would be the edges of my square in this case. I've got the actual height comes from the tip down to the center of the base. And then I have the slant height, which goes down the side, or you could think of it as the height of the triangular lateral faces. And then we've got the lateral edge, or the lateral edges, which come from the tip down to the corners, the vertices of my bases. So there are 4 potential things that we can be given, and we'll be given 2 of those. So let's go through a couple of examples and see how that works out. So we've got a square pyramid with base edge 10 and slant height 15. So I guess our first challenge is to draw this. So yes, I do expect you to try to draw this on your paper. I'll walk you through how I do it. I try to usually start with a sort of a parallelogram-ish base. And then pick a point that's going to be your top, and then just kind of draw lines as best as you can going down from there. And no, it doesn't always look great, but that's okay. And that last one's going to be technically like a dotted line if you want to do that. So give it a shot, see what you can do, and then let's label what we've got. So base edge is going to be 10. So I've got 10 inches there, here, and technically all of these sides. That is a square. And then slant height is 15. So that's going to be straight down perpendicular to the base edge on the side. I usually find it easiest to draw on this side. And that's my 15 inches. So goal is to find the area of the lateral faces, the ones that are not bases, and then total surface area would just be adding in that base. And then we're going to close off with finding the volume. So let's start with the lateral area, which is going to be none other than area of triangles. So I'm finding the area of this triangular face, and I'm recognizing that I actually have 4 congruent triangular faces. So once I find the area of that, then I can go ahead and multiply that by 4. So the base is 10 I've got for my base edge, which is a base edge triangle, times 15. I'm given the height. And then I'm going to multiply that by 4. So that gives me 5 times 15 is 75 times 4, which gives me 300. Square inches for my lateral area. So I'm going to go over here and recognize that the base area is 10 squared, which is 100. Not hard, but that base could take on any shape. That could be a regular hexagon, pentagon, or any other shape. So in this case, not too bad. Total surface area is going to be my lateral area plus my base area. So if you break it up, it just kind of makes it a little easier to see what you're doing. So we've got the 300. We're going to add the 100 to that. So 400 square inches for the total surface area. And you're thinking, wow, this is so much easier than the prisms. Yeah, sort of, until we get to the volume. And we are going to have to do a little bit of work here. So on the volume, volume formula, this one I believe is on your air formula sheet. We looked specifically at the relationship between a cone and a cylinder and found that the cone is 1/3 the volume of the cylinder if it has the same base, same radius of the base, and same height. So pyramid works the same way. A square pyramid would be 1/3 of a cube with the same edge length, and the same height. So 1/3 times capital B times H, 1/3 base area times height. So I'm going to put my information in there. Base is this 100 is going to go over here because remember this is the same as my BA that I found. And now I just need to find the height. So when we say height, we're looking for the height of the pyramid, which comes from here straight down to really the center of the base. Picture the point in the very middle of the square. So it's going to come down to there, and it's going to come, well, that is my height, but I'm going to try to find that height. So in order to find that height, I'm going to do what I always do, which is make a triangle. And that's going to be the right triangle that I use. So I'm not sure if you can follow that. I know it's a little hard to see with these pictures. But I just made a right triangle that goes halfway across the base, which means the base is 5. That is, again, halfway across this. So this would be 5, and this would be the other 5. The height is unknown, and this is my 15 that I started with. So that's my 15. And this is my unknown, unknown height. So hopefully you're seeing something that you can do to solve for that. 5 squared plus h squared equals 15 squared. I'm not going to do that for you right now. I'm going to tell you that you should have gotten for your answer square root of 200, which is 10 radical 2, and let's go over here, and that's going to be 10 radical 2. So the final answer for this volume, when I plug that in, is going to be 100 times 10 is 1,000. That doesn't divide evenly by 3, so I'm going to write as 1,000 radical 2 all over 3 cubic inches, and that was my volume. So you got the idea. That's very similar to what we did with the prism. Notice our lateral faces are triangles instead of rectangles. So that's a big difference when you look at the makeup of a pyramid versus a prism. Let's try another one. So same deal as last time. You're welcome to follow along or give it a shot on your own. This one gets a little more complicated. You'll find out as we go through this, but same start as what we did last time. So let's try to draw a picture. So again, I'm going to try to start with that square base. That's what I usually find easiest. And as best as you can draw sort of up to a top point. This time I know the base edge is 14, so I'm given that again. Cool. So I know where to put that we can put here, or we can put here. And then the lateral edge is 25. So lateral edge is this. Any of those. So if you need to go back to the beginning of this video, I looked at the different things. And this one, instead of giving the slant height, I'm giving that lateral edge. So the first thing I'm going to find is try to find the lateral area. So again, I have 4 triangles. So 1/2 base times height times 4 should do it. 1/2 times base edge is 14. So I'm looking at one of these faces. So base is 14. And the height, so when I get to the height, then I'm going to recognize that I actually don't have the height. The height would be this right here, straight down perpendicular to the base. So I'm not sure what the height is. I'm going to have to do a little work, and I'm going to actually pull out this triangle that we're looking at. Oh yeah, a right triangle. There it is, a right triangle on the side. That's a different right triangle than I used in the last one. So that right triangle is formed by unknown height, except we don't actually use height for that, since h is usually h is reserved for the height of the actual pyramid. So we're going to use the letter L. A lowercase script L is what we use to refer to the slant height if you want to use a variable, or you could pick your own variable. The hypotenuse of that triangle is 25. And then the base, see if you can figure out the base. I'm right here on my picture. Yep, you got it. It's going to be 7. So we're going to put, a 7 right there. And there's a good old right triangle. So how am I going to find the length of L? So I'm seeing a right triangle. And I'm going to do some good old Pythagorean theorem. And you can do the work on your own. and figure out that that comes out to be 24. So my height is 24. Let's put that in. And that gives me 7 times 24 times 4. Final answer, 672 square inches for the lateral area of my pyramid. Base area is going to be 14 squared, which is 196. So my total surface area is going to be the 672 plus the base area, which is 196. Again, that's my base area, for a final surface area of 868 square inches. And now I'm on to volume. You're saying, yeah, this isn't too bad. I agree. Not too bad. 1/3 base area times height. Again, this is my base area, and I know that that is 196. So I've got 1/3 times 196 times my height, and again, the height's not drawn in there. So, whoops, let's draw that in there and try to make that look as good as we can. So go to the middle of the base. So that's my unknown height. And problem is that that's going to be shorter than my 24 that I got, because my 24 right here is this slant. So that's actually the hypotenuse of, you're seeing another right triangle, hopefully. So let's sketch that out. Right triangle with a height, with a base edge of 7. So that's coming from this right here, which is half of my distance across here. And then my hypotenuse, which is that 24, which is really the same thing as this, the way those triangles are oriented. So see if you can follow that. And now we've got to go back to, yep, Pythagorean theorem, you got it. H squared plus 7 squared equals 24 squared. So h squared plus 49 equals, I'm going to let you do the rest of that on your own, because I'm out of space here, and h should come out to be radical 527. That's a fantastic number. So radical 527, I do not believe that that simplifies, so we're just going to go with that. And that gives me, pretty much, I'm going to keep that the same for the volume. And the only thing that I did different for my final answer is I put the 3 in the denominator. And I wrote it like that. Oh, come on, iPad, cooperate. And remember, that's cubic inches in this case. Hopefully that helps you out and gave you a little bit of a challenge. I did give you a square pyramid to try on your own, so flip the page over and have fun. Good luck with the next one.